Sec 2, Chapter 1, Linear Inequalities. Now, in this part of the lesson, we'll be looking at some of the basic properties of linear inequalities and how do we represent linear inequalities on number line. Right, now let's take a look at the following first question over here. Question say, solve the inequality 4x greater equals to 34, and then you need to represent your solution on a number line. So now how do we work out the answers for this? We will start off with 4x to be greater than or equals to 34. Now what we're going to do, we're going to find x. How do we get rid of 4? We need to divide by 4 on both sides. Notice that we are dividing by a positive number, so there is no change in the direction of the inequality symbol. So now we have 34 divide by 4, and that gives me the number 8.5. Okay, when I want to solve this inequality, I'm writing the whole thing over here as my solution. Not just 8.5, the whole thing over there is the solution. And how do we represent this number on a number line? Okay, now first part, we need to call out our ruler for us. And what are the numbers that we may need? I need, in this case, 8 and 8.5 and 9, right? So probably I'll need a number that has, using 1 cm to represent 1 unit. Maybe I'll just put 7, 8, 9, 10. Okay, I may not need to use the whole number line, just a part of the number line will do. So in this case, I'm going to keep my ruler. Oh no. So let's say this number is 7. Here. Then this number is 8. This is 9, and then maybe 10. Okay. And now we need the number 8.5. So using my ruler, I'm going to measure where is 8.5. 8.5 is right in the middle. Right? So this number here is 8.5. Now there are two types of circles to represent the inequality. One is the empty circle. One is the solid circle. Now, what does the empty circle and solid circle means? Empty circles are meant for number that is less than or numbers that are greater than, where there is no equal sign, because it means I do not include that number. But in this case, this one is a greater than or equal to symbol. So if I were to have a less than equal to or a greater than equal to sign, where I have the portion where they say I can include that number, then I'll need to draw a solid circle. So in this case, I have x is greater than or equal to 8.5. Can I include 8.5? Yes, right? We can include 8.5. And this one is do not include. So what will it be? Will it be an empty circle or a solid circle? Since I can include 8.5, that means I'm going to draw a solid circle. Above the number line, do not touch the number line. In this case, I'm just drawing a range of the values, right? Not marking one particular point, right? So I draw a range of values. Now I want the portion where x is greater than 8.5 or equal to. So greater, all the numbers on the right hand side are greater than 8.5. So that means I'll need to draw it in this direction. And this one will be my answer. Okay. Next part, part B. Using your answer to part A, find the smallest possible value of x. Where x, okay, the first part, smallest possible value of integer value of x. What does integer means? Integer means the whole number. So in this case, can I include 8.5? Well, 8.5 is not an integer. And I want numbers that are bigger than 8.5. So in this case, my nearest possible integer, smallest possible integer would be the number 9. Okay. Next one, find the smallest possible value of x if x is a prime number. So what are all the prime numbers that is bigger than 8.5? Prime numbers, what is a prime? A prime has only two factors, 1 and itself. So is 9 a prime factor? Well, 9 is divisible by 3, so it has more than 2 factors already. So 9 is not a prime number. So what's the smallest possible prime number? That will be 11. Okay. Next, what other values can x be if x is a rational number? What does rational number means? Rational number means any number that is a fraction or a number that is a decimal with repeating pattern. Okay. So in this case, if I want a rational number can be either a fraction or it can be a decimal with a repeating pattern, or call it a recurring decimal. So in this case, find the smallest possible value of x. X can be a fraction. That means x can also be a decimal in this case. So now 8.5 is 8.5, right? So it's actually a fraction. So my smallest possible value x will be the number 8.5. Because 8.5 can be written as 8.5, it can also be a fraction. Have you gotten your answer? Now let's move on to the next part. The next part of the question says, question number 2, solve the following inequality, and then we need to represent this solution on a number line. So I want to solve this inequality. First up, I have 2 minus 5x greater than 13. I'm going to keep my x on the left hand side. X is the subject as I solved it, and I'm going to shift the numbers together over to the other side. So this is positive 2, okay, added plus 2, right? So I shift it over, I'll need to have subtract 2, so I get 13 minus 2. 13 minus 2, that gives me 11, okay, negative 5 greater than 11. Now how do we get rid of negative 5? I only want x. Well, we divide by negative 5. Okay, so if we were to divide by negative 5, remembering we are dividing by a negative number. When we divide by a negative number or we multiply by a negative number, the inequality direction will change direction. Okay, so it changes to the other side over here. So this is 11 divided by negative 5, and I get a number negative 2.2. Now, question says solve the inequality. So the answer is not negative 2.2. The answer is the whole inequality itself. So in this blank down here, please make sure you write x lesser than negative 2.2. Okay. So now we are going to draw this number line to represent our solution. Since there is negative 2.2, we will probably need, let's say I just start from 0, negative 1, negative 2, negative 3. So this is 0, this is negative 1, negative 2, negative 3. Where is negative 2.2? Okay, 2 units and a little bit more, 2.2 over here. Please use your ruler wisely to measure. The best is to use 1 cm to represent 1 unit, unless the scale is unless the number is really very large. If not, then you can at least like read the scale properly. So this number is negative 2.2. Now, do I use an empty circle or do I use a solid circle? Solid circle means I have to include 2.2. But empty circle means I do not include the number 2.2. So in this case, since this inequality symbol here is less than, did not say equal to, so I have to use a empty circle. I'll draw it above the number line, floating a little bit, and I want all the value of x smaller than. Where is the portion that's smaller than? Well, all the numbers on the left hand side over here are smaller than the 2.2. So this is my answer. Okay. Using this solution, x must be negative, smaller than negative 2.2. Find the largest possible integer of x. What's the largest possible integer? Integer means whole number, right? X must be smaller than negative 2.2. Now, very common mistake, some of you might write an answer as -1. Are you sure -1 is smaller? Well, numbers on the right hand side, this is bigger and this part is smaller, right? So what's the largest possible integer value that is actually smaller than -2? Well, -1 is not the answer. The correct answer is supposed to be -3. The more negative the number, the smaller the value. Okay. Now, let's continue with the next page. Over here. Now, we have learned how to draw the inequality on a number line. But do you know how to read the inequality from the given number line? So let's say I've already drawn this for you. How do you write an inequality to represent this range of numbers? So for example, over here, I noticed that the only number that is necessary over here is 5.5. So I definitely have 5.5, right? And then this is an empty circle. So empty circle only got two inequality type, either is less than or is greater than. So usually when there's only one end in this case, there's no two ends to the number to the diagram, only got one end over here. So we usually start with x as the subject, and then I know it's 5.5 is my value. Then I need to decide, okay, is it bigger or smaller? All the numbers here is smaller, all the numbers here are bigger. So in this case, I want this range. So x must be bigger than. If it's bigger than, that means the crocodile mouth is facing the x, eating a larger piece. X is larger than 5.5. And since it's not a solid circle, it's an empty circle. So there's no equal sign. It's just greater than, not greater than or equal to. Okay, so this is the inequality that represents this range of values. Have you gotten your answer? Now let's look at part B. What do you think if we were to have this kind of inequality? Okay, you notice that my values is in between two values, in between a -2, in between a 4. That means the x value are in between two ends. There are two ends to it, the -2 and the 4. Okay, and therefore x definitely must be greater than -2, smaller than 4. The next thing we want to check, this over here is a solid circle. Solid circle, so that means it includes the number -2. So that means I need to add the equal sign over here. And this one over here is an empty circle. So this is do not include the number. So in this case, there's no equal sign over here on this side, right? So this is the final answer. So x is in between -2 to 4, but it can include -2. Have you gotten your answer? Okay, next part. Now, question says that given that x and y are integer, using my answer to part A, so it says x must be bigger than 5.5, but x is an integer. What are the numbers that x can take? Integer means whole number, right? So what are the numbers x can take? 6, 7, 8, 9, 10, 11, 12, so on and so forth, right? What about value for y? Oh, right, wrongly. This one's supposed to be y. Oh, sorry. Yeah. This is y. I never read the question. I'm so sorry. Okay, so this one is y. So now my y is the range between -2, can include -2, okay, to 4. So y is from -2. It includes -2. So I get -2. Bigger than, so -1, 0, 1, 2, 3, 8. Do I include 4? Now question over here, this one is a less than sign, right? There's no equal to, so it does not include 4. So it stops at the number 3. Now question asks me to find the largest possible value of y minus x. If I want the largest possible value of y minus x, that means I'm going to take the largest y, which is 3, minus away the smallest value of x. Which one is my smallest value of x? Oh, 6 over here. So my smallest value of x is 6. So 3 minus 6, that will give me negative 3. Okay? Next one, find the smallest possible value of x squared plus y squared. Smallest possible value. I know x is 6, 7, 8, dot, dot, dot. So what is x squared? 6 squared will be 36. 7 squared, 49. 8 squared, 64. Some more, right? Other values. What about y? Y goes from negative 2, negative 1, 0, 1, 2, 3. What if I have y squared? What is negative 2 holding square? This number is actually, if you key inside your calculator with your bracket, right, it's actually 4. Negative 1 holding square, that will give you positive 1. Okay, so if you didn't press your brackets in your calculator, you may get a negative 4. Then your answer is not correct. 0, 1, 4, and 9. Now, question says, I want the smallest possible value of x squared plus y. So the smallest possible value of x squared will be 36. Plus the smallest possible value of y squared will be 0. So the answer will be just simply 36. Have you gotten the answer? Next, let's find the smallest possible value of y over x. Before we begin, let's see, should we get a negative number? Or should we try to get a positive number? Right, what should we try to get? We should try to get a negative number, right? Smallest possible value, as negative as possible. So in my x range, x have 6, 7, 8. Then y have the numbers negative 2, negative 1, 0, 1, 2, 3. So technically speaking, I want y over x. I'll probably choose a negative number. I want it to be as negative as possible. Okay, so probably I'll choose negative 2. We have a couple of options. Negative 2, then what am I going to divide with? Okay, I want it to be as negative as possible. So probably I'll take negative 2 divided by 6. That gives me negative 2 divided by 6, which gives me the option 1/3. Right? 0.3333, negative 0.33. What about some students may be sure, what about if I use negative 1 over 6? What's negative 1 over 6? Negative 0.166. Which one is smaller? This is negative 0.333. This one is negative 0.1666. Which one is more negative? Smaller. So this answer will be smaller, right? What about if I were to choose negative 2 divided by 7 instead? Maybe I choose the larger number, negative 2 over 7. What will I get? I'll get the number negative 0.2857. So you compare negative 2 over 6 and negative 2 over 7. This is still the smaller number. Smallest possible value will hence be negative 1 over 3. So for this part of the question, you need to probably try and error a little bit along the way, right? And find the most logical answer. I want it to be small, so a negative number is definitely smaller than a positive number. And next, I want it to be as negative as possible, so I can try the different denominators to see whether which answer is smaller, right? Okay, let's move on to the next part of our work. Last page. Oh, now solving inequalities. Okay, at first we'll deal with our fractions a little bit later, but let's deal with basic inequalities first. For example, if I start with 3x minus 2 less than 5x minus 7. First, we'll group all the x over to one side. Now, some of you might group your x to the right hand side and make it positive. If you do that, remember, make x your subject in front. But since I want to make x my subject, so I'll just do 3x. I'll shift 5x over. But this is positive 5x. This is addition. So I'm going to do a subtraction. Okay. The inequality sign stays in the middle. There's only addition, subtraction, no change in direction of the inequality. The original citizen on this side is -7. Somebody migrated over. This is -2. It migrates over. So this is -2. Then it become, cross over this side, become +2. Right, I'm adding, I undo subtraction, so I add. Right, so in this case, I get a number -2x less than -7 minus a plus 2 will give me the number -5. Next, how do I get rid of -2? So we divide by -2. If I were to divide by -2, I'm dividing or multiplying by a negative number. What will happen to my inequality symbol? The inequality direction will change direction. Why is that so? Because negative number, right? Okay, for example, negative, if I were to just say 1 and 2, right? 1 is smaller than 2, correct or not? But if I were to multiply by a negative sign, -1 and -2 becomes smaller than -1. So the effect of multiplying by a negative number will change the direction of the inequality symbol. So here I get x, then that will be -5 divided by 2, -2. So give me 2.5. Either you can write it in decimal if the answer is exact value. If the answer not exact, you put it in a fraction. Okay. Question, do I write? So is this my answer? So usually we say solve the equation, this is the answer, right? Inequality. But read the question. They say find the smallest possible integer value x that satisfy this equation. They are not asking me to simply solve for the inequality. So in this case, this is not the answer. And I want x to be greater than 2.5, and it must be an integer value. Integer means whole number. So what number can x be such that it's bigger than 2.5 and it's an integer? Well, the answer is 3. So this should be my final answer. Okay, do read your question, okay, in case there's a trap for your question. Right? Next question. Solve the following inequality. Now we're going to move on with a little bit of fractions. Okay, for me usually I don't like denominators, so the first thing I'll do is I try to get rid of all the denominators. Right, our denominator over here is over 3. 3 is my denominator, so technically speaking I'm going to multiply by 3 to get rid of my denominator. But I need to be fair. If I want to multiply by 3 to the first fraction, I need to multiply by 3 to every single term inside the whole inequality. So if I multiply everything by 3, this one will, if I were 3 times 3, will give you 5. -2 times 3, -6. 4x times 3, 12x. So that's my first step. Then now I'm going to shift the terms around. Okay, this one is +12 shifted over across the border, change the passport, so become -12x. Then nobody is the citizen here, so somebody migrated over. This is -6. You come over this side, it will become a +6. Okay, so I just write 6 will do. And simplifying, 5 minus 12 gives me -7x. How do I get rid of -7? I'm going to divide by -7. So I'm going to divide by -7 on both sides. Remember, I'm dividing or multiplying by a negative number. So what will happen to our inequality symbol? it changes direction. So this is x greater than or equals to negative 6 over 7. Okay, question says solve the inequality. So in my answer blank, I need to write the whole inequalities. Okay, there's a range of answers, not just only one number, negative 6 over 7, then it will not be correct. You write the whole inequality inside. Next part, fractions again. Now, some students say, I cross multiply or whatever, or make it into one single fraction. Alright, then you cross multiply. Okay, no, for me, I don't like to do that. I just like to simply multiply with the denominators through every single one of them. So I have the denominator 2, 6, and 3. What number should I multiply such that the denominator will disappear? All the denominators will disappear. In fact, my largest denominator, 6. What is the LCM, lowest common multiple of 2, 6, and 3? The LCM is actually 6. So what I'm going to do, I'm going to multiply everything by 6, everything by 6, everything by 6. So up first, the fraction over here, 13 over 2, multiplied by 6. That gives me 39. Okay, so I'm going to multiply fraction by fraction. The first one over here, 13 over 2 times 6, that gives me 39. So I get 39x minus 5 over 6 times 6, that gives me the number 5. Greater than or equals to, this one is 3x over 3 times 6. 1 times 6, 6 long. 6x. Okay, and here I must have written a typo, must be got colors mistake. Okay, never mind. Shifting our x together on the side, one same side, 39x minus away 6x. Remember to change the sign, right? Greater than equals to, this one, the negative 5 go over to this side, becomes positive 5. Okay, and simplifying this, 39 minus 6 gives me the number 33x. Greater equals to 5. I'm going to divide by 33. My number is not an exact decimal, so in this case, the best way is to keep it as a fraction. 5 over 33. Notice I'm dividing by a positive number. The inequality sign does not change direction. Question says solve the inequality. So I copy the whole inequality as the answer into the blank. Have you gotten your answer? So some of the concepts for fraction for me, I don't like denominators. So I'll multiply every single term by the denominator. So if the denominator has more than one number, we can just simply multiply by, let's say got 2 and 3, right? So just times 2 times 3, which gives me times 6 lah. Okay. Next one, word problem. Now Jane is given $45 to buy X souvenirs. Okay, one souvenir costs 85 cents. Form an inequality in X. Okay, and solve the inequality and find the maximum number of souvenirs that Jane can buy. First things first, are the units the same? Now this one is $45, but that is 85 cents. So I'm going to change this to 85 cents. 85 cents, so $0.85, right? And now they say one souvenir is 0.85. So I want X souvenir. How much will that cost me? So that will cost me 0.85 times price times the quantity, right? Times X number of souvenir. I'm given $45. Can I exceed or spend more than $45? That means it must be less than, right? Cannot, right? Can I spend exactly equals to $45? Yes, right? So in this case, the inequality over here is 0.85x less than or equal to the number 45. Right? Next, they say solve this inequality. So I just simply divide by 0.85. I don't want 1. the 0.85. Then I get x. So 45 divided by 0.85 gives me the number 52.94. Oops, the number, since I do not know, I'm going to change it to fraction. So x must be smaller than or equals to this. What is the maximum number for souvenirs? Since it must be lesser than or equal to 52 16/7, so the nearest integer whole number will be 52 souvenirs. Have you gotten your answer? Okay, with that, we have come to the end of this part of the lesson. We'll see you for the next lesson. Goodbye.